Alright, welcome back to Film Reality Check. Let's talk about the movie that made every kid think cloning dinosaurs was just a matter of finding mosquito in amber. Jurassic Park. Now, we all remember that scene where they pull DNA out of a fossilized mosquito, mix it with a frog, and boom, dinosaur. But is that actually possible? Can we really extract DNA from fossils? So here's how Jurassic Park solved it. Scientists find a mosquito trapped in amber, suck out its dino blood, and sequence the DNA to bring dinosaurs back to life. Sounds cool, right? But there's a tiny problem. DNA is not immortal. It's more fragile than a Sydney sharehouse lace. Even under the best conditions, DNA falls apart over time, like a sausage left out in the sun. Radiation, temperature, humidity, all break those molecular bonds. Scientists have actually measured this. Under perfect conditions like cold, dark, dry, DNA has a half-life of about 521 years. That means after about 6.8 million years, even under perfect conditions, every DNA bond would be broken. And guess what? Dinosaurs went extinct 66 million years ago. So by the time we get to T-Rex territory, the DNA is just not degraded, it's confetti. The oldest DNA ever recovered is from a 1 to 2 million year old mammoth tooth found in permafrost in Siberia. That's like 100 times younger than any dino fossil. And even that one was hanging on by a thread. So no, the idea that mosquitoes' blood can survive for 66 million years is about as likely as your iPhone battery lasting in a week. Alright, but what about the amber itself? Doesn't it preserve everything perfectly? Not quite. Amber is great for preserving shape, not biomolecules. Fossilized insects look perfect on the outside, but their insides? Long gone. Researchers have tried extracting DNA from amber-trapped insects, and they mostly get modern contamination, like a DNA of the poor postgrad who sneezed near the sample. So while you can see the mosquito beautifully preserved, its content, including that dino blood, are basically dust.
Dust. Anybody?
Alright, so we can't clone dinosaurs, but what can we do? Turns out ancient DNA science is exploding right now. We can sequence Neanderthal DNA, reconstruct extinct mammoth, and even compare them with elephants. Scientists are working on de-extinction, bringing back recently distinct species like the woolly mammoth or thylacine using CRISPR and cloning. Because their DNA is still relatively intact, tens of thousands of years old, not tens of millions, and that's the key difference. Time. DNA is like a memory card. After a few million years, it's unreadable. Just realized I didn't button up my shirt. Alright. Let's say, hypothetically, we could extract dinosaur DNA. Should we even bring them back? Well, think about it. You'd need to find a compatible egg, which doesn't exist. A suitable surrogate species also doesn't exist. And then somehow raise a 5-ton apex predator in the lab. And we all saw how that went in the movie. Badly. We can't even keep pigeons taking over train stations. Imagine dealing with the dinosaur problem in downtown Melbourne. There are some scientists working on Jurassic Parkish stuff though, like colossal biosciences, who want to bring back mammoths.
Colossal Biosciences
Develops cutting-edge technology to protect biodiversity and reverse human caused extinction.
They're using CRISPR to insert mammoth genes into elephant DNA. That's not resurrection, it's reconstruction. More like building a mammoth cosplay out of elephant parts. It's fascinating science, but it's not time travel. So, can we extract dinosaur DNA from fossils? Short answer, no. Long answer, not unless you've got a time machine, a freezer from Mesozoic era, and a very forgiving ethics board. But hey, science still amazing. Even if we can't bring back T-Rex, we are bringing back the story of life, one genome at a time. And maybe that's the real magic of Jurassic Park. Not the dinosaurs, but the curiosity it sparked. Thanks for watching, Legends.